Welcome back. This is the third lesson recording for IM1, January 8th, 2021. So now we're going to be deciding if a sequence is arithmetic or not. Okay, to check if a sequence is arithmetic, since arithmetic sequence is always going to be adding a particular constant number, what we can do is we can subtract the next term with the current term. Okay, so then see if the difference is the same, that is common for all consecutive terms. So for example, if you have 90, 73, 56, and 39, the first 90 is my A1, 73 is my A2 or second term, or 56 is A of 3 or A sub 3, and 39 is A sub 4 or A of 4. And so what we can do is get the second number, that's 73, A of 2 minus A of 1 is going to be 73 minus 90, 73 minus 90, and that's going to give me negative 17. So you're always going to be dealing with the current and then take away the previous. Okay, current take away the previous and you get negative 17, and that tells me that common difference is negative 17, so we think. But we need to check the other ones too. A of 3 or A sub 3 minus 8 of 2, 56 minus 73 is also 17, negative 17, and 39 minus 56 is also negative 17. If one of them is off even just a little bit by 0.01 or something like that, it is still not a arithmetic sequence. It has to be exactly the same. It can't be just close. It has to be exactly the same for all of them. Okay, so yes, this is arithmetic sequence with a common difference of negative 17. Okay, then how do we decide if it's a geometric series or sequence or not? To check if a sequence is geometric, you're dividing the next term with the current term. Okay, so then see if the ratio is the same for all consecutive terms. So for all of them, not just one of them. So if you have 21, 147, 1029, and 7203 in your as your terms in your sequence, this is the first term S of 1, the second term, third term, and the fourth term. So you get the second term and you can subtract. Oh no, since we're checking for geometric, we're going to divide. So 147, that's whatever we're looking at, divide by the previous one, that's 21. So current divide by 21, previous, that's 21, and that's going to be 7. What about 1029 divided by 147? That's also 7. And then finally, 7203 divided by 1029 is also 7 exactly. So this tells me that it is a geometric sequence with a common ratio of r is equal to 7. Okay, so now you are going to go back to the decimals and you are going to finish the rest of the cards. That's card number 15 all the way to card number 20. Okay, so here we are trying to decide, is the sequence arithmetic, geometric, or neither? Well, looking at 42 and 19, the number is getting bigger. Is the number getting bigger by a constant amount? Then we need to figure out, okay, so what we can do is we can do 42. We can do 42. That's the second term minus the previous term, which is 19. And that's going to be 13. No, it's 23. Okay? Then what about the third term? Take away the second term. 65, take away 42. If it is arithmetic, that means the difference is going to be the same. 65 minus 42 is also 23. So those two check out. What about 88? Take away previous term, which is 65. And again, that is 23. So since the difference is 23, so you are increasing by 23 and 23 and 23 here. I know that this is arithmetic. Okay, so I am going to click arithmetic here. Okay, and what is the common difference? The common difference is, so I can write D is equal to 23. Okay, and then I'm going to submit, and then I am going to clear and go to the next card. Okay, is the sequence arithmetic, geometric, or neither? 0.2, 0.6, 1.8, and 5.4. Okay, the numbers are getting bigger. So that means it could be adding some number or it could be multiplying some number. Okay, so to do that, let's check if it's arithmetic. So to do that, we are going to get the second term. That's 0.6. Take away its previous term, which is 0.2. And that gives me 0.4. Okay, what about the next one? 1.8. Take away the previous term is 0.6. Okay, and that's going to be 1.2. Remember, subtracting decimals, you need to line up the decimal point. So you are subtracting like this. 8 minus 6 is 2. 1 minus 0 is 1, so it's 1.2. Notice that the difference is different. 0.4 and 1.2. We don't even have to check the third one because it has failed the difference test, common difference test. So I know that it is not arithmetic. Now let's see if it's geometric. Okay, so to check if it's geometric, you are going to look at the second term divided by the first term. So that's going to be 0.6 divided by the first term, or the previous term, that's going to be 0.2. And that comes to 3. How many 0.2 fits into 0.6? 3. What about the third term divided by its previous term, which is 0.6? So it's 1.8 divided by 0.6. And again, that is 3. Then we also need to check the last term. We're not done until we've checked every single one of them. So then that's 5.4 divided by 1.8. It's the previous term, and it is also 3. So since the dividing the term with its previous term is leaves us with constant number, we can say this is geometric. Okay, so I'm going to click my geometric. Okay, and then it's asking you what is the common ratio, and I'm going to say the common ratio R is equal to 3. Okay, and then I am going to submit. All right, then let's get rid of you. What about this sequence? Is the sequence arithmetic, geometric, or neither? 24 is becoming 20. So what did I add? Well, it looks like I added or I subtracted by 3. So I can say I added -3. But from here to there, or -4, I'm sorry. But from 20 to 17, it looks like I added -3 here. And then -2. Okay? So the difference is changing. It's not constant. So that means this is not arithmetic. Now is a geometric. Then to do that, we need to check the previous divided by the number, the term divided by its previous. That's 20 divided by 24. That's going to be same as they're both divisible by 4. So 5 over 6. Okay. What about 17 over 20? This is not 5 over 6. This does not simplify to 5 over 6. That means it's not geometric either. So if it's not arithmetic, we've just proven that. And it's not geometric, then it's going to be neither. So I am going to click on neither. Okay, and explain why. Because I checked for common difference and the differences are not constant. And I checked for common ratio and the ratio of the term with its previous is not constant. I have 5 over 6 for the first, the second one will be 17 over 20, and they're not equal. So that's why. Okay, let's move on to the next card. Arithmetic or geometric, 20.5, 7.5, negative 5.5, negative 18.5. Okay, so we need to check by subtracting 7.5 minus 20.5. Okay, so 17.5 minus 20.5 to see if it's arithmetic. Okay, so in this case, okay, how do I do this? Certainly you can use the calculator or you can find the difference. Okay, we're becoming more negative. That means the final answer is going to be negative. And it's the difference between these two is actually 3. So it's negative 3. So you are going down from here. Okay, oh, actually, I'm sorry. This is 7.5. So if I subtract 20.5 minus 7.5, I get 13.5. So the difference is I am subtracting by 13.5 or adding negative 13.5 here. Okay, so if I add another 13 or subtract 13.5 from 7.5, am I going to get 5.5? Okay, so 7.5 take away 13.5. Okay, so we're trying to do that. The answer is going to be negative because I am taking away a bigger number from a smaller number. Okay, and the difference between 13.5 to 7 is actually 6. Okay, so we have it's okay. Oh, I'm sorry. No, it should be 13. So I'm taking away 13 from 7. Okay, so then um, 7.5. So I am taking away another 6.5. So I should end up with negative 6.5. Actually, scrap that. That should be negative 5.5. Okay, so yes, this is you are adding negative 13.5. Okay, so now let's add another negative 13.5 to negative 5.5. So if I add 13.5, I meant if I take away 13 from negative 5.5, I do get negative 18.5. So that means the difference is constant. So yes, this is arithmetic, and the common difference is negative 13. Okay, I'm running out of time, so please pause the video and read the instruction, and I'm going to give you the answer. So on the first day, she collected 1, second day, she collected 7, third day, 13, and the pattern continues. So this will be the sequence. And since you have the common difference of 6, it is arithmetic. For the last card, we're starting with 820 chicken nuggets. And then each person that passes through the lunch gets 6 chicken nuggets. That means it's decreasing by 6 every single time. So 820 becomes 814, 808, and 800, and so on. So in this case, again, this is arithmetic. And this is the last card that